relative velocity. In under this section now we are going to discuss speed of approach and speed of separation. Now suppose these are the two particles, particle A and this is particle B. These two particles are moving with a velocity Va and the second particle is moving with velocity Vb along an angle alpha, making with this line AB. This angle is beta. So the separation between these two A and B, these two particle A and B is S, and if this separation is decreasing, then this is called velocity of approach, or simply in other word it is also called speed of approach. If the separation between these two particles is increasing with time, then this is called velocity of separation. Now velocity of separation and velocity of approach are mathematically same expression. So we can see the velocity of this particle A along this line is Va cos alpha, and the velocity of this particle B along this line is Vb cos beta. So velocity, now if I say the separation between this A and B is S, and if this separation is decreasing, means Va cos alpha is more than Vb cos beta. So I will write velocity of approach is the rate of change of this distance A and B, and that is equal to minus ds by dt, which is equal to Va cos alpha minus Vb cos beta. And in the same way, if the separation between A and B is increasing, in that situation Vb cos beta is greater than Va cos alpha, and in that case we can say the separation between these two is increasing, so velocity of separation is plus ds by dt, that is equal to Vb cos beta minus Va cos alpha. If you see these two expressions, approach, velocity of approach and velocity of separation, then you will find the value of ds by dt is again in these two expression is same. Mathematically these two expressions are same. In the same way, suppose this particle A and this particle B. Suppose A is running in this direction with a velocity Va and B is running in this direction with a speed Vb. And if this angle is beta and if this angle is alpha, then we can say the separation between these two is increasing. In that case, velocity of separation becomes plus ds by dt, and that is equal to Va cos alpha plus Vb cos beta, because both the component, both velocity component along this line is increasing this separation between A and B. So the separation is increasing at a rate of Va cos alpha plus Vb cos beta. Now watch this video, the use of velocity of approach and velocity of separation. See this video. In this video, a cheetah is approaching a deer, and this cheetah is trying, this leopard is trying to catch this deer. This is a video about the velocity of approach and velocity of separation. This cheetah starts running. It is running towards this deer, and the deer is also running. The cheetah is always running towards this deer, and this cheetah is now approaching this deer. Now after some time, this leopard is about to catch this deer, and when it catches, the deer increases its speed, and the separation between this cheetah, this leopard and the deer starts increasing. And again this cheetah increases his speed, and he starts approaching this deer. So this is the velocity. The separation between these two now is decreasing. This is the velocity of approach. Now we will analyze this video. Now initially this cheetah starts running towards this. Initially this cheetah starts running towards this deer. The separation between this cheetah and this cheetah is running with a speed Vc and this deer is running with a speed Vd. The separation between these two initially is decreasing, so we will write ds by dt is equal to Vc minus Vd. This is the velocity of approach. This is called velocity of approach. Now, after some time, this cheetah is again catching this deer. So this is the velocity. If this cheetah is running in this direction, this is Vc, and the deer is running in this direction, Vd, at an angle beta, let this angle be alpha. So we can say the separation between these two. The separation between these two is S, and this S is decreasing. So I will write minus ds by dt is equal to Vc cos alpha. This is the velocity of this cheetah along this line, along this deer. This is Vc cos alpha. So I will write it Vc cos alpha minus this component is Vd cos beta. This is the velocity of approach. Now this cheetah, the distance between these two is decreasing, and after some time what happens, this deer increases its speed. This deer, when this deer increases its speed, this is Vd, and Vd, if Vd is greater than Vc, this is Vc, then the separation between these two is again starts increasing. So I will write plus ds by dt. This is the separation when the deer increases its speed, that is equal to Vd minus Vc if these two are running along the same line. So this is now the velocity of separation. After this video and after this discussion, we will start solving some questions. Now suppose this is a particle A, this is particle B. Let the separation between these two initially is d. These are the two particles A and B. These two particles this A starts running with a speed with an acceleration A. This running starts with a constant speed V at t is equal to 0. A is at rest. Then the separation between these two at any instant, we can say A is here and this person B is here. This is separation. So the separation between these two initially increases, it becomes maximum, and then it starts decreasing. So I can say the velocity of separation is ds by dt, and velocity of separation is v minus velocity of A, that is equal to A into t. This is velocity of separation. If I say velocity of approach, then velocity of approach is minus ds by dt. In that case, the velocity of A at that instant is more than velocity of B. If VA is greater than V, then the separation between these two starts decreasing. So in that situation, I will write it as AT minus V. So this is the velocity of approach and this is velocity of separation. If V is greater than AT, then the separation between these two is increasing. If AT is greater than V, then in that situation the separation between A and B is decreasing. And if I say when these two will catch, so when these two will catch, in that case we will start from here. ds is equal to V into dt minus AT dt. After integration, initial separation between these two is d, and finally when the meet is 0. So this is from 0 to t, this is from 0 to t. So we get minus d is equal to V into t minus 1 by 2 A into t square. Solving this, we will get time when the two will meet. This is quadratic. The positive value of time will give you the time when these two person will meet. Now suppose 3 points. Now this is a question. 3 points are located at vertices of an equilateral triangle. This is an equilateral triangle. This is particle A, B and C are located here. The side of this triangle is A. They all starts moving simultaneously with speed V constant in magnitude, with the first point headings continuously towards the second and the second for the third and third for the first. How soon will the points converge and what is the total distance covered by each particle? Now in this question we can solve it like this. Suppose this person A, this particle A, this particle B and this particle C, it starts moving towards this A, this C starts moving towards A starts moving towards B and B starts moving towards C. Now after some time this particle A is here, the particle B is here, the particle C is here and so on. So the length of the side of this triangle will go on decreasing. So this distance will go on decreasing. Let this distance be L. Initially it is A. So we can say the velocity of approach. Velocity of approach is equal to minus ds by dt. And if you watch this person A and B, this is person A and this is person B. Let the separation between these two be S. So A is moving toward this person with a speed V. B is moving towards this direction with a speed V at an angle of 60 degree. The rate of change of decrease of this distance is the velocity of approach, and this is equal to V plus V cos 60. So it is V plus V cos 60 degree. This is the velocity of approach of A and B. So velocity of approach is minus ds by dt, that is equal to V plus V cos 60 means 1 by 2. So it is equal to 3v by 2. This is the velocity of approach between A and B. Because at this instant also VA is in this direction, VB is in this direction. So the separation between these two is decreasing with the same rate. At any instant the rate is of decrease of this distance is always same. So now we can say minus ds is equal to 3v by 2 into dt. So if I integrate it, starting from t is equal to 0, the separation is a, and finally when they meet, this distance, that separation becomes 0. So we get a is equal to 3v by 2 into t, or t is equal to 2a by 3v. This is the time when all the particle will meet at the center of this triangle here. All this particle will meet at the center. Now if we say what is the total length traveled by a particle, suppose we have to calculate this distance moved by this particle A, this distance L. Now we know distance L is equal to speed into time. We know its speed is V and time is T, because the speed is constant, so it is equal to 2a by 3. So the total distance traveled by any of these three particles is 2a by 3. This is the answer. 6 particles situated at a corner of a regular hexagon of side length A moves at a constant speed v. Each particle maintains the direction towards the particle at the next corner. Calculate the time when the particle will meet each other. Now suppose this particle A, this is particle A, it is moving towards this B, and B in turn is moving like this. So I can say the separation speed, the velocity of approach is equal to V minus V cos 60 degree, because we know this angle is 60 degree. Now the separation between these two is decreasing with a rate of V minus V cos 60, and at any instant the particle will follow a path like this. All the particle will move like this, and they finally meet at a single point here. So at any instant the approach velocity will remain same. At this instant the approach velocity is same. So velocity of approach is V minus V by 2, that is equal to V by 2. Now we can say approach velocity is minus ds by dt, and that is equal to V by 2. So from here we can say minus ds is equal to V by 2 into dt. On integration, initially at t is equal to 0, the separation is a, and finally at time t the separation becomes 0. So we get a is equal to v into t by 2, or t is equal to 2a by v. This is the total time taken by this particle to converge starting from corner, and this is the answer. Point A moves uniformly with velocity v, so that the vector v is continuously aimed at point B, which moves rectilinearly and uniformly with speed u. At the initial moment, the point A was moving perpendicular direction of motion of B, and the points are separated by a distance L. How long will it take the point to converge? Now suppose this point A is here, the point B is here. The point B is moving with a constant speed u, but this point A is always moving while aiming this B with a speed v. Let the separation between these two initially is L. It is given the separation between these two is L. Now after some time A is here and the B particle is here, and this B is moving with a speed u, whereas A is always moving toward this B with a speed v. Let at any instant this angle be theta, so I can say this angle is also theta. Let the separation between A and B be S. So we can say The separation between A and B is S, and this separation is decreasing, so minus ds by dt. That is the velocity of approach. If you watch the separation along this line AB, you can say the speed of rate of change of the distance is v minus u cos theta. This theta is variable, v and u are constant. So from here I can write ds is equal to v into dt minus u cos theta into dt. Let the time t when they all will meet here. Now in this case I can say on integration, I can say integration of ds is equal to integration of v dt minus integration of u cos theta into dt. At t is equal to 0, the separation is L, and finally when they meet, the separation becomes 0. So let them meet at time t. So from here I get L is equal to 0 minus L minus is L, that is equal to v into t minus u integration of cos theta into dt from 0 to t. Because this theta is also function of time and the relation is not known, so this is our first expression. Now see this particle A. Along x-axis, if I choose this as x-axis, along x-axis the speed of particle A, velocity of A along x-axis is v cos theta, and this is equal to dx by dt. So from here I can say dx is equal to v cos theta into dt. On integration I can say at t is equal to 0, the x coordinate is 0, let this the origin be here and this be y. So at t is equal to 0, x coordinate is 0, and after time t let the x coordinate is x. So from here we get x is the total horizontal displacement of this particle A, that is equal to v integration of 0 to t cos theta into dt. Now x, this x is the total distance moved by this particle B. This is x, and this x is also equal to u into t because B is moving with a constant speed. So from here I can write this is equal to u into t. This is our second equation. Now from first and second, from this expression, first expression L is equal to v into t minus integration 0 to t u cos theta into dt, that are L is equal to vt minus u integration 0 to t cos theta dt, and u into t is equal to v into integration 0 to t cos theta into dt. This is our first expression, this is our second expression. From this first expression and from this second expression, now we can say from second we can say integration of 0 to t cos theta dt, that is equal to u into t by v. So if I substitute the value of this integration cos theta dt in this first expression, I get L is equal to v into t minus u square t by v, or t is equal to L into v divided by v square minus u square. This is the time when this particle A will catch this particle B. This is the time, and if I know this time I can very easily calculate this x. X is u into t. This is the x coordinate moved by the particle A along this x axis. In this question, two ships A and B originally at distance d from each other depart at the same time from the same coastline. Ship A moves along a straight line perpendicular to the shore while B constantly head for ship A, both having the same speed. After sufficient long time, the second ship will catch the first one at a certain distance from the coastline. Find that distance. Now suppose this ship B is always moving toward this ship A. Ship A in turn is moving with speed u. This is moving with speed u. The speed of A and speed of ship B both are equal, let it be u. Now the separation at an instant, the ship B is here and the ship A is here. The separation between this ship A and B is S and the separation is decreasing. Let this angle is theta. Let this angle be theta. This question is same as that of the previous one. So this ship B is again moving with speed u. It is moving with speed u. So the separation between these two is minus ds by dt is u minus u cos theta. It is u minus u cos theta. The separation between this A and B is decreasing with a rate of u minus u cos theta. So I can say minus ds is equal to u dt minus u cos theta into dt. On integration, we know initially the separation between these two is d. After sufficient long time, let the separation be x. So we can say d minus x is equal to ut minus u integration of 0 to t into cos theta dt. Now again the problem here is integration of this is 0 to t cos theta dt, because this theta is not constant, it is variable. Now for this, the distance traveled by this ship A is v u into t. This is the distance traveled by ship A, while the ship B is moving along x-axis with a speed of u cos theta. So distance moved by B, ship B, is integration of u cos theta into dt from 0 to t, and this distance let it be xb, and we know xb is equal to, it is u integration 0 to t cos theta into dt. So this is separation, this is the displacement of ship A along x-axis, this is displacement of ship B along x-axis, and we know the ship A is here, the ship B is here, and both are moving with speed u. So the separation between these two is x, and this x will remain same. So now we can say xa minus xb, that is equal to x. So from here I can say xa, we know xa is equal to u into t, and xb, that is equal to u integration cos theta into dt, and xa minus xb, that is equal to x. I will substitute the value of xa here, means ut minus u integration 0 to t cos theta dt is equal to x. This is our one expression, d minus x, that is equal to u into t minus integration of 0 to t cos theta into dt. Now we have to calculate the final value of x. So I will substitute the value of u cos theta, integration of u cos theta into dt, that is equal to, it is ut minus x in this expression. So I get d minus x, that is equal to ut minus ut plus x. So this 2 will cancel out. We get d is equal to 2x, or x is equal to d by 2. This is the separation between these two ships, the ship A. This question: a swimmer capable of swimming with a speed v and water of the river is flowing with a speed u. U is less than v. If d is the width of the river and swimmer always swims towards a pool on opposite side of the river, find the time when he will touches the pool. Now this swimmer is always swimming while pointing towards the pool. This is the swimmer, he is always swimming towards this pool. Initially the separation between the pool and the swimmer is d. At any instant, let at any time t, the swimmer is swimming in this direction with his speed v and the water is flowing with his speed u. The separation between this pool and the swimmer is s. Now if I say this angle is theta, Let the horizontal axis makes an angle theta. This angle is theta. So I can say the rate of change of distance. This is swimmer A, this is pole, and this is swimmer. Swimmer is swimming with speed v, water is flowing with speed u, and this angle is theta. This angle is also theta. So we can say the separation between this pole and the swimmer is decreasing, and the rate of decrease of this separation is called velocity of approach, that is equal to v minus u cos theta. This component of velocity is decreasing the separation, whereas u cos theta is increasing. Pole and the swimmer, line joining this pole and the swimmer, is decreasing at a rate of v minus u cos theta. So this is the velocity of approach of this swimmer towards this pole. So we can say minus ds, that is equal to v into dt minus u cos theta into dt. So on integration, let the swimmer catches this pole in time t. So in time t the separation becomes 0. Initial the separation is d, and finally when he catches it the separation becomes 0. So from here we get d, that is equal to v into t minus u integration of cos theta into dt. Here again cos theta is variable. Since cos theta is variable, so we can never integrate it without knowing the theta as a function of time. So now assume the velocity of the swimmer along x-axis. The velocity of the swimmer along x-axis with respect to ground can be written as v cos theta minus u, because water is flowing in this direction with speed vu and the swimmer is moving with speed v. So the horizontal component of velocity is v cos theta minus u. Vx is dx by dt, so it is equal to v cos theta minus u. So dx can be written as, it is v cos theta into dt minus u into dt. On integration, at t is equal to 0 we know x is 0. When he will catch this pole in time t, again the x coordinate becomes 0. Suppose this is our x-axis, this is our y-axis. Initially the swimmer starts from origin, and again when he catches it the horizontal displacement is 0. Here x is 0 and here also x is 0. So x initially is 0 and x finally is 0. So from here we get v integration 0 to t cos theta dt, that is equal to u into t. This is our second expression, this is our first expression. Now from first and second I can say d is equal to v into t minus u integration 0 to t cos theta into dt. This is our first expression, and from second expression, which is equal to v cos theta, v integration 0 to t cos theta dt, from second expression we can say v integration cos theta dt from 0 to t, that is equal to u into t. This is our second expression. From first and second, if we eliminate integration 0 to t cos theta dt, I can say d is equal to v into t minus u. This can be written as u into t by v. I will substitute the value of integration 0 to t cos theta dt, that is equal to u into t divided by v. If I substitute this value in expression 1, I get like this. So from here we get t, that is equal to d into v divided by v square minus u square. This is the time when the swimmer will catch this pole. This is the answer. When this person walk on this stair, he reaches in time t1, that is equal to 90 seconds. So let the speed of walking of this man be u and let the length of this be l. So we can say l is equal to u of man into time, that is 90. When standing on the escalator, now moving, he is carried up in 60 seconds. When he is standing on escalator and escalator is moving, then the time is 60 seconds. In the second case, he take only 60 seconds to reach this point. So I can also say L is equal to this V. Let the speed of escalator be V. Let the speed of this man be U. So U into T 90 is L, and when only he is standing means U is 0. So in that case this man reaches the highest point, this travel this distance L in time 60 seconds. So this is 60. This is our first expression and this is our second expression. How much time will it take while walking up the moving escalator? Now if escalator and the man both are moving, then the speed becomes U plus V. So I can say L is equal to U plus V into T. Let the time now is T. So from here I can say L is equal to, I will substitute the value of U from here, it is L by 90 plus V means L by 60 into T, or T is equal to, on solving it this L will cancel out, on solving it we get it is 90 into 60 divided by 150, that is equal to 36 seconds. The distance between two moving particles P and Q at any time is A. If Vr be the relative velocity and if U and V be the component of Vr along and perpendicular to PQ, then their closest distance is AV by Vr, and that the time is AV by AU by Vr square. Now we'll solve this question like this. Suppose this is particle P, this is particle Q situated at distance A. The separation between this P and Q is A. Now the relative velocity between P and Q is Vr. Now we are assuming this Q to be moving and P to be stationary. With respect to P, this Q appears to be moving like this with a speed of Vr. So it is Vr. The component of this Vr perpendicular to this line PQ is U, and along this line it is V. It is given. This is V. Now the particle is moving such that this theta, this is U. P is stationary and Q appears to be moving on this line. So we'll draw a line. Q appears to be moving with a speed of Vr on this line. Q is some time here, after some time it is here, after some time it is here, after some time it is here. And when it is here, this distance is the minimum distance. When the Q is at this point, the separation between P and Q is minimum and the time is T. Now we have to calculate this minimum distance. Now from this triangle we can say this is smaller triangle. I can say tan theta. Tan theta is equal to V by U. Cos theta is equal to, if you see cos theta, it is U by Vr. And if you say sin theta is V by Vr. Now the minimum separation, if you see this triangle, this is a right angle triangle, the minimum separation is D, and D is equal to, we can say it is A sin theta. So the minimum separation is A, and we know the value of sin theta from this figure, from this expression. So it is A V by Vr. This is the minimum separation between this particle P and Q. Now for time. For time we have to calculate this length. Now with this length is equal to this length L, from this to this point, this L is equal to A cos theta, because this is a right angle triangle. So the time is T is L by, it is Vr, and we know L is A cos theta by Vr. So from here I can say it is A cos theta is U by Vr. So it is AU by Vr square. This is the time when the separation between P and Q is minimum. Now see, two particles A and B move with constant velocity V1 and V2. This is particle A and this is particle B. They are moving with the velocity V1 and it is moving with the velocity V2. Initially it is at distance L1 and this distance is L2 from origin. T is equal to 0, L1, L2 from, find the time when they are nearest to each other. Now suppose this particle A is moving along this line, particle B is moving along this line. Now with respect to, now velocity of, I can say velocity of particle A is v1 I cap, and velocity of particle B is equal to v2 j cap. Now I can say velocity of A with respect to B is v1 I cap, it is velocity of A, is velocity of A minus velocity of B with respect to ground. So this is equal to v1 I cap minus v2 j cap. So if this person B is stationary here, this is the velocity of A with respect to B. This component is v1 and this component is v2. So I can say this angle theta, I can say tan theta is v2 by v1. So this BA is moving along this line with a constant velocity. It is v1 I cap minus v2 j cap. Let the minimum separation between these two be d. Now we have to calculate this d. This is the minimum separation. The particle, when particle A is here, the minimum separation A and B is d. Let this distance be x. Let this distance be x. Now I can say this distance is x, then this is your L2 minus x. This is L2 minus x. This is L2 minus. If this angle is theta, I think this is 90 minus theta. This is 90 minus theta, and this is theta. This theta and this theta is same. So now we can say tan theta from this triangle is x by L1, and that is also equal to v2 by v1 from here. Now from here we can say x1, x is equal to, I can say x is equal to v2 by v1 into L1. This is our first expression. Now from here I can say if this is x, this is L2 minus x. Now we can say d is equal to L2 minus x into cos theta. So d, that is the minimum separation, is L2 minus x. X means v2 into L1 by v1 into cos theta. If you see tan theta is v2 by v1, then we can say cos theta is v1 divided by root over v1 square plus v2 square. This is cos theta. Now d is equal to L, this is L2 v1 minus v2 L1 divided by root over v1 square plus v2 square. This is the answer. This is the minimum separation between this particle A and B. Now see, 2 point A and B are moving with speed v and 2v. This is particle B and this is particle A. Particle A is moving with speed v and this is moving with speed 2v. The speed of this particle B is 2v. On a concentric circle of radius 2r, this radius is 2r and this radius is r. The point moves in the same sense. This A and B both are moving in the same direction. If angle OAB is alpha, means this angle is alpha, it is given. Find the value of alpha when the relative velocity is along this line AB. We have to find the value of alpha when the velocity of AB is only along this line joining this particle A and B. Means the velocity of A and B is along this line, means their component perpendicular to this is 0. If I say this angle is alpha, angle is 90 minus alpha. Let this be theta. Let this angle be theta. So now by using the property of triangle, because we know this angle is 90 degree, so I can say at this instant r by sine alpha must be equal to this 2r by sine 90 plus theta. 90 plus, by using the property of by sine rule, we can say r by this sine alpha is equal to 2r by this. This is theta plus 90. This is our first expression. So from here we get cos theta is equal to 2 sine alpha. This is our first expression. The velocity of A and B is along only this line, so their perpendicular component will cancel out. So we can say 2v sine theta must be equal to v sine 90 minus alpha is cos alpha. This is our second expression. When their vertical velocity, the perpendicular velocity will cancel out, then only the velocity of A and B is along this line joining these two particles. So this v will cancel out. We get this sine theta is equal to 1 by 2 into cos alpha. So from here, if we square these two and add, we get 4 sine square alpha plus 1 by 4 cos square alpha is equal to 1. Now after solving it, we get cot alpha is equal to